some marathon there. Okay, yes, apologies for the break in transmission all the time. So, like I was saying, that this week we are starting with um, Azure Compute and Networking
Ma'am, I
services.
can't hear
And
you.
uh, are you saying something, Susie? Oh, sugar. Okay. I hope you can still hear me.
Yes, I can hear you now.
Thank you. Thank you very much. I'm really sorry.
I can hear you now.
So, all right, thank you. So, Azure Compute is an on-demand computing services for running cloud-based applications majorly. It provides computing resources like multi-core processors uh, and supercomputers via virtual machine using hypervisor technology and containers services as well. So it's also provide what we call serverless computing to run apps and then without requiring infrastructure to be set up or infrastructure configuration. So we will talk more about serverless computing later as a course in the course. So there are four most common techniques for performing computing services in Azure. Which one of them is virtual machine, and we have containers, that's container instances, and then we have Azure App Services, and we have serverless computing. Each of them have a virtual machine that is powering each of the services. They have those virtual machines have resources like processors, like memory, require networking for it to be able to talk to itself, talk to any other virtual machine within its environment, and talk to the outside to other computers outside of itself or of its environment. And on top of it, also they make use of one form of operating system, either Windows or Linux operating system. Each of those virtual machines that is powering each of these services have the operating system that they are using. Though depending on the service that you are using, you might have access to the virtual machine and you might not have access to this virtual machine. The access or the management capabilities you have on them will reduce based on or depending on the type of service you are using. So let's now look closely into virtual machine. If you recall in one of our lessons, I said a cloud, that's Microsoft Azure, is powered by virtualization technologies. I've also made mention of it this evening, right? So virtualization uses software. That's what it uses software to create an abstraction layer over a computer hardware. This abstraction layer allows the hardware elements of a single computer, like the processor, the memory, the storage, and every other component of that hardware to be divided into multiple virtual computers. So commonly, these virtual computers are now commonly called virtual machines. So with that understanding, if I say what is or what are virtual machines, they are actually uh, computers, just like the word virtual, take it like that. You cannot touch it, or you can actually feel it and use it. So they let you create that's what virtual machines do. They just Azure virtual machine just allow you to create virtual machines in the cloud. That's virtual computers that you use to host your application. So they provide infrastructure as a service. in form of a virtualized servers. In form of a virtualized servers. Though you can have a virtual machine that is also running a client operating system. So when we mean virtualized servers, we are talking about a machine that is running server operating system, like a Windows Server 2012, a Windows Server 2016, or a Windows Server 2019, or running the server version of Linux operating system. So you also have virtual machines in Azure that can run client operating systems like Windows 10, Windows 11. Am I sure of Mac? I'm not sure, but you can actually set up a client computer running Windows 10 and Windows 11 in Azure. Yes, you can run machine with Mac. I just remember that. So just like physical computers, right? You can customize all of the software running on the VM. So when you hear VM, it's just a short form of virtual machines. So VMs are an ideal choice when you have the following requirements. One, the total control. You need a total control over the operating system. So that means you want to be responsible for the type of OS that is running. You want to be responsible for patching and maintaining that operating system. When it comes to security of it, you want to be responsible for it. The application that is running, which is the ability to run custom software. So it might be that you are building your own, you are a developer, for instance, or your developers are developing their apps and they feel it is better to be hosted on a virtual machine because they require some form of customization that might not be available when you use the app service option of Azure. So in this case, you'll be going for a virtual machine as against using app service. Also, when you need to use custom hosting configuration, you will also be making use of virtual machine. So you can create virtual machine. I think in the lab that we did last week, we were able to create a virtual machine. If we were not able to do the lab on our own, we were able to see during the call how to quickly provision a virtual machine and connect to it. Um, so you can create a virtual machine in minutes, and then that means you have to select a what we call a pre-configured virtual machine image. So that means the image that is provisioned, the OS is already installed. It's just for you to say, okay, run it, run this particular image. So that allows you to be able to do that. Then you can use virtual machine templates also to create your operating system. So this way, you have a template. In that template, templates are like settings. They're like settings that you put together that a particular service or a particular thing or component must have. Or there are components that you put together that when you set up a virtual machine, that virtual machine must have all of the components that you state in your template. So the template can include things like the version of the operating system you want it to run, the VNet, that's the virtual network that that virtual machine should connect to, whether it should have IP assigned to it statically or it should have it assigned automatically using dynamic host configuration protocol. You want to state all of those there. Then you want to state whether you want some other services like antivirus to already be installed on it. That is what we really they call template. Template are just a container that contain a settings or a set of instructions for a particular task to be completed or to be performed. So that is majorly about virtual machines. So if you have any question, please do not hesitate to stop me and then ask. So we move on from here. Now let's look at VM scale, that's virtual machine scale set. So virtual machine scale set allow you to centrally manage, configure, and then update a group of identical load identical or load balanced virtual machines in minutes to provide high availability or highly available, to make your application highly available. So what we mean is, if you want to run a website, for instance, you can create a virtual machine. Now, you realize that there are so many loads on that, or so many traffic coming or hitting your web server. So now you want to scale. So what you can do is to automatically already provision the VM in such a way that, depending on the load or depending on the traffic that is hitting the VM, is to add another set of the same VM to it. And that VM should be running the same exact service that is running on the first VM, it should be on the second one. Now, for you to be able to direct traffic here and there, you will need to implement some form of load balancing services, which is also available in Azure. So the number of virtual machine instances can automatically increase or decrease in response to demand, like I said, in response to demand or a defined schedule. So if we know I have a commerce site and I have a single virtual machine that hosts my commerce site, I know that during Easter period, I will have a lot of requests. A lot of people come to my website to purchase items. So I can create a schedule that every April, every first to second week of April, increase the number of virtual machines that is hosting my e-commerce site, increase it to maybe 4. Then distribute the traffic as they come. Make sure at least when traffic user 1 try to request, that traffic go to server 1 from the set. User 2 try to request, the traffic go to server 2 from within the set as well. So the moment the Easter period is over and that level of high traffic, high volume of traffic is reduced, then reduce the number of virtual machine in the set, reduce it back maybe to 2 or 1. So with the VM scale set, you can build large scale services for areas like compute, like big data, like container workloads. So that's majorly what our VM set. Like we said, we just use the website to kind of explain what it means. So, but if you don't understand, please, you are free to call my attention so I can break it down. But just take it as you having a website that enables. Okay, let's use scientists now. This analogy that I will have used this one. That enable maybe a set of scientists or any scientist out there to upload an astronomy image that needs to be processed, right? So if you duplicated the VM, you will normally need to configure an additional service to route the request, which I talk about, which is the load balancer, to be able to say when maybe route traffic from 10 scientists to server 1, route traffic from the next 10 scientists to server 2, like that, and so on and so forth. That's majorly what virtual machine scale sets are used for, to increase the load and to decrease the load automatically or at a schedule. Now, there is also what we call virtual machine availability sets. Uh, so the availability sets here is talking about what we call fault domains. And what are fault domains? Fault domains, what it does is it group you group virtual machines, you group them together. That's VMs that are, excuse me, you group virtual machines together based on whether those virtual machines are sharing common power or common networking. And majorly, this fourth domain have to do with updates. So take for instance, if you have a website like that scientist website or file upload website that we talk about, or your e-commerce website, right? You have about about 10 virtual machines hosted there. The thing is, when you want to roll out updates to those virtual machines, you will not be pushing the update to all the servers at the same time. You need to identify the VMs, that's the virtual machines that can restart at a time without it disrupting your service. So let me say, okay, let's leave the website on now. Let's look at this instance. I have a domain controller, a virtual machine running a domain controller. I have a virtual machine, right, that is running Exchange server. I have a virtual machine that is running antivirus. Then I have a virtual machine that is running Windows update services to update the servers. Then I have a virtual machine that maybe this virtual machine is responsible for certificate. So what you need to do to create a fourth domain or virtual machine availability set is you need to identify if my user need to authenticate, it means at all time, the domain controller must always be reachable. Then between domain, so that means I can restart domain controller now. Now, if my user needs to antivirus, I have antivirus server, and this antivirus server does not push, user don't go to it to request things. It's the one that download update from the internet and then pushes it to his computer. But it's already at a schedule. So it doesn't do it every minute or every seconds. It does it only at a schedule period. So it means if I restart this particular virtual machine, nobody will feel the impact. It's not going to affect any service. Unlike the domain controller, if I restart a domain controller, user might be trying to authenticate as at the time of restart and they will not be able to authenticate. That means they will lose access to the services that they need to access. So it means I can take split it, saying domain controller can be in availability set 1 and the antivirus server can be in availability set 2. Now, looking at the Windows update server, if I now want to deploy the update and I need the VM to restart, yes, it's going to pull the update from that update server. So I might not need to restart that update server yet. It has to be up to. Then finally, let's look at the certificate server. The certificate server, once a machine joins the domain and it requests a certificate, it doesn't go back every time to go and request the certificate until that certificate expire and it need to request again. So it means the certificate server can go down. It can restart at any time and it will not affect any service because no machine is actually querying it every second. So um, I can group uh, the certificate server and the antivirus server. I can group them together and make them that way they will become a machine, a fourth domain in a particular fourth domain, maybe fourth domain 2, right? Why I have domain controller and the update server in fourth domain 1. So every machine, a particular fourth domain can go down without affecting the other machines. So let's leave that. Let's go back to our website. If I have 8 virtual machines in a web for hosting a website in total, I have four hosting the app service, the website itself, while another four rather, are hosting, another four are hosting, or let me say two are hosting, four is hosting web server, two are hosting the database that the web server is talking to, and another two is hosting maybe load balancer. Yes, that's good, load balancer. So what we can do is to say, out of the 4 web server, we can allow 2 to go down at a time. Then out of the 2 database server, we can allow 1 to go down. Then out of the load balancer, we can allow 1 to go down. So I can group the 2 web server plus 1 the database server plus 1 load balancer. I can push update to them, those 4 at the same time, while the other set of 2 web server, 1 database, and 1 load balancer continue to function. That is majorly what virtual machine availability set is all about, to identify machines that can restart at the same time without affecting services. So we'll be looking at this later. This is creating virtual machine, which of course we did last week. Though our lab also contain instruction how to install web service, web server package. We didn't do that when we set up the virtual machine in the class. We only installed the VM. So we'll come back to that later. Now let's look at another service in the compute service, which is Azure Virtual Machine Desktop. Azure Virtual Desktop, rather, sorry. So, this was Azure Virtual Desktop is a desktop and application virtualization that runs in the cloud. It runs majorly in the cloud. And this became more pronounced when the era of during COVID, where a lot of people have to work from home, and then organizations now face different challenges. One of the challenges they face is the company computer that employees take home. Uh, After a while, because they have been working from home, they do not have a way by which they could communicate with the company's servers, like the like the Active Directory for them to continue authenticating, like the update server for them to continue to receive updates. Though they can receive updates on the internet, but that will tell more on their internet bandwidth as opposed to when they are in the office. The company is responsible for the bandwidth that is being used to deploy updates to computers. So now, with some of these reasons, and also it's not just that, it might be a requirement where an organization say, okay, for all our staff, if they must work from home, we cannot assign machine to them. The machine they are using, it means must be the data on those machines must be controlled by the organization at all time. So that might be because of some compliance requirement, right? And it will also be to manage consultants within an organization. If you have a business that you make use of consultant a lot, you want a situation whereby when you are they are working in your environment, your data stays with you. They do not take your data out of your organization. So that way, the risk of data theft or computer being stolen, which will lead to unauthorized access, because now they are consultants. They are not your staff or employee that you really have more control over, or they are consultants. You cannot tell what they are doing when they are not, or when they are various places. When they are place, you want to create a virtual environment, a virtual desktop environment where all they need is just another device and internet. They just log into a URL, and then they are presented automatically, or a Windows 10 or Windows 11 will automatically be provisioned for them. And within these windows, there will be all applications that they need, which include Office application, their Microsoft 365, different browsers as they might need. If they are developer, they will even add Visual Studio and some other developer tools for them, that machine. So that is majorly what the idea of virtual desktop is. It helps organizations to reduce risk of being left, risk of being left behind session. So we can have even two virtual machines created within the virtual desktop environment, and more than two people use it. It's by session. So more than two people are actually connecting to the same machine at the same time. And when each person connect, they have their own personalized desktop without disrupting what the other person is doing. So that is just the way virtual desktop work. Now let's talk about uh, Azure Container Service. So Azure Container Services are virtualization environment, but however, unlike virtual machines, you do not manage an operating system. You do not manage the operating system that the container itself run or that is powering the container service. You don't manage it. If I think somebody asked a question last week based on the assessment I was given for last week class, asking that um, to uh, um, state the attribute or property or what is common, I think something like that, with virtual machine and containers. The person was asking that, isn't that she thought container does not use operating system. It actually does. It has its own operating system, but you don't manage that operating system. Yes. Okay. What's going on? Uh, yes, I'm still presenting. Okay, okay, no problem. Is anybody still seeing my screen? I need to be sure. Can I still seeing my screen if I continue? Hello.
Yes, ma'am.
Okay, thank you. Okay, so like I said, containers also have operating systems that they use. But majorly containers are meant to be lightweight, and they are designed to be created, scaled out, and then stopped dynamically. So it means um, container service are actually platform as a service offering that runs a container in Azure without the need to manage the underlying virtual machine or the additional services that powers the container. So you just focus on your own services that you are running without you bothering about how to manage the virtual machines and the networking and any other thing that come with it. Azure Kubernetes service also is similar. It also have operating system, but does not, you don't manage it as well. So Kubernetes service majorly is an orchestration service for containers with distributed architecture and large volume of containers. So what this means is Kubernetes service are services that allow you to be able to, if you have created a lot of container services or container instances, and then you need to be able to automate some processes within the container, you can use Kubernetes service to perform or to carry out that automation. That is majorly what container service and Kubernetes service help you with. Now, finally finally, Azure Function. So Azure Function are serverless computing. I talked about serverless computing a while ago. So as we hear it, function, majorly what it does is event-based code running your services and not the underlying infrastructure. It's like I said again, it's a form of serverless computing, and it is the evolution of cloud platforms in the direction of pure cloud native code. Pure cloud native code. So it brings developers closer to business logic, while insulating them from infrastructure concerns. So it means why they are not consigning themselves with the underlying infrastructure. They just want to run their code as they have it, and then be able to create some logics behind it. So I will give an instance, right, where we have a form that is hosted in a particular website, and what we the form is hosted on Azure, right? And we created a function service, majorly an event in a function for an event, that each time somebody filled that form, get a copy of the form, extract certain information, maybe extract the person's names, the email address, the phone number, take this information, the extracted information, use it to create an account, uh, maybe on your domain controller or something, or on a particular app service that you have. Use it to create an account for the person. When you create the account finish, now, after the account, the moment there's a submit button that is hit, the next thing is send an email to that user with the account information. Now, username and password for the person to log in. And if you need him to do any other thing, is to send it alongside. So that's majorly what Azure Function does for you. It's a pattern that doesn't imply no server, but rather less server. That's where the serverless comes from. Less server. There is server, but there are less servers that are responsible for running that services. And serverless code is event driven, like I said. Code now may be triggered by anything from a traditional HTTP web request, like filling a form, or it might be as a result of somebody uploaded a form. So let's take another example, right? If you have on your website, you have HR, oh sugar, my battery is low. I didn't realize I didn't plug it. Give me some minutes, let me plug my battery, my laptop. Okay. So now the HR, the moment a uh, a potential candidate uh, fill a form, send it to HR. From there, they will automate every aspect of it to interview, send a mail to the person, assign this particular calendar day for interview. The person after it after the interview, if the person is, or if the candidate is shortlisted or going to be to the next stage, he automate it like that until the person comes into the organization. Now, when the person has been employed, it's go continue the function continue from send a mail to the IT department to provision a system, a phone, and everything the person will require to carry out his work. Then a mail to account or send all the details of the user, of the employee, extract some information and send it to the account to arrange or add that person or that particular candidate's information to the list of employees payroll and all of that. So that's actually another way you can make use of Azure function in under computing service. Now comparing the three compute, three common compute services together, we have the virtual machine, that's virtual desktop and container service. So cloud-based virtual machines are cloud-based servers that support either Windows or Linux environment. While virtual desktop provide cloud-based personal computers, like I said, desktop experience, that's end user machine like Windows 10, Windows 11, Windows 8, like that. Then while container is a lightweight miniature environment well suited for running microservices. So microservices is a type of service for development, for application development, where you create your development or application, you create them in many components. So in such a way, when you are updating or a component break, it does not affect another component. That is microservice. Then virtual machine is useful for lift and shift migration to the cloud. So if you are migrating your resources from your on-premises data center, you can actually migrate those machines directly to the cloud while you plan how you convert virtual machines to maybe other type of services. Then for virtual machine, for virtual desktop rather, it's dedicated applications to connect and use or accessible from any modern browser. So it's majorly you need another device, and from your browser, you connect to the virtual machine and you are provisioned or you are provided with a desktop client computer. Then for container service, it's designed for scalability and resiliency through orchestration, which is using
Hello, ma.
adding, yes.
The slides are not changing. It has just been synced.
Which slide are you seeing?
VM availability sets. That's where it has made sense.
VM availability services. Wow. You might need to disjoin and rejoin. Who else is seeing that same page? I'm currently on comparing Azure Compute option. Is that where you are?
Yeah, that's what I'm saying.
Okay, Susie, can you disjoin and rejoin quickly?
Okay, all right.
Yeah. Thank you. So for compute service, for virtual machine rather, it's a compute operating system packages, including the host operating system. Sorry, it's a complete operating system package, including the host operating system. While for virtual desktop, it's a multi-client login. So it's created in sessions. So you have multi-client log that allow multiple users to log in into the same machine at the same time. So it is powered by a form of remote desktop. That's when you create a server, for instance, you can remote to that machine. By default, two people can remote to to the server at the same time, but using different accounts. So somebody can be using administrator, another can be using maybe TT to log into that same machine. But if you need more people to connect to it, to that same computer, then you need to license it by purchasing virtual machine, uh, remote desktop license. So the remote desktop license will now allow more users to connect to that same computer at the same time. So it's the same thing that is powering the virtual desktop in the cloud. Why container service, on the other hand, is applications or runs applications and services. They are packaged in a container that sits on top of the host operating system. So multiple containers can sit on one host computer. Multiple containers can sit on one host computer. So take containers just like multiple briefcases that you keep certain component or tool in. So, but then they are all occupied in the same room. So that's the way it is. So app services uh, are they are platform as a service also, fully managed platform to build. It's majorly for developer as well. So it allow you to be able to build your develop your code, deploy to app service, and scale the web apps, and then also connect to the web app or to the app service using API. And the process is very, very quick. So with app service, you can work with uh, environment or yes, environments like .NET Core, Node.js, Java, Python, or PHP. Uh, uh, so Azure App Service allow you to be able to run such web services. And then, like I said, it's a platform as a service service option. And then it's very secure and allow most organizations to meet compliance. So that's majorly app service. It's used majorly by developer to quickly host their services. Finally, looking at Azure networking. Azure networking services, it's majorly called VNet, that's virtual network in Azure. It enables Azure resources to communicate with each other, with one another. So I can create, if I want two virtual machines to be on the same IP subnet, what I need to first do is to create a virtual network. That virtual network will have a subnet assigned to it, both private and public subnet assigned to it. So I will have to also state what set of IP in that subnet will represent my gateway. That's default gateway that the computers will be getting. Then I can now set up virtual machines. When I create virtual machines, instead of it to create a virtual network on its own, it will automatically, or not automatically, I will have to select the virtual network that I want it, that's a VNet that I want it to use. So that way, every computer using that VNet will all be on the same subnet, and they can talk to one another. It's as if you just carry a switch, just a normal switch, your standard switch, and connect multiple computers on that switch and give each of them IP in the same subnet. So we can pick a subnet of 192.168.1.1 /24. So /24 is subnet mask will be 255.255.255.0, right? So if we have something like that, every machine that we assign IP to, that does 0 or /24 give us about 254 hosts. That's 254 computers or IPs that can be assigned. So it means if I now have like 10 computers connecting to that same switch and all in that same subnet, they can all talk to one another. So for VNet, when creating it, you can create public endpoint. So public endpoint allow you to be able to access the internet. And then private endpoint allow you to be able to connect just locally within your network. So that you can have servers that you do not want to go to the internet. You just want them to only be accessible internally. In such case, you will be creating a VNet with just private endpoints. But if you want a server that needs to be reachable on the internet or that needs to go to the internet, then that's VNet. The VNet that VM is using must also contain public endpoint within it. And like I said, when you are creating your virtual network, you need to divide the subnet. You need a subnet, and the subnet needs to be divided into multiple segments, depending on what you need. So where you this might be useful for you is you have web servers, you have your database services, and you have Active Directory servers. You have which other service? Let's leave it as that. Or you have some other management services that you use in monitoring the network. So you can divide the subnet into four to say the domain controllers will be on this subnet. Then the other subnet will take the web services, while another subnet will take the database services. Then another subnet will now take the management tools that you use in managing those servers. So you can then create some kind of security or firewall to allow communication between each of those subnets that you have created. So that's Azure services in a nutshell. Sorry, Azure Network Services in a nutshell. So on the Azure Network Service, actually, we have what we call private, we have what we call virtual VPN as well. So virtual VPN actually allow you, or virtual private network, so that's VPN, allow you or is used to send encrypted traffic between Azure Virtual Network and an on-premise location over the public internet. So this is useful if you have your servers hosted in your local data center or a rented or co-located data center, and then you want to start moving your resources to Azure. You will need to create a virtual network, and that virtual network must have a gateway. The gateway that we're talking about here is going to be carrying public endpoints, going to be public internet. Now, between this public gateway, this gateway in Azure that have public internet, you need to configure site-to-site VPN between this gateway and um, your on-premises firewall that takes your server to the internet. You establish VPN connectivity with them. That way you are creating a tunnel. So what it means is every traffic, every data that passes through your on-premise firewall gateway passes through that VPN to reach Azure is being encrypted, is secure. So only you can see it. That's majorly what this virtual VPN does. And like I said, it's IPsec, so it's a tunnel. And now when you are creating this tunnel, the on-premises firewall have its public IP, the Azure firewall, Azure gateway have its public IP. Then in Azure, you have a VNet that is private, carrying private endpoint, a private endpoint VNet. And on your on-premises also, you have your internal private IPs that your servers are carrying. So while creating your VPN, you need to have all of this information for you to be able to establish a VPN connectivity between Azure and your on-premises um, data center. Then another way by which you can connect your on-premises data center or link them together with Azure is using what we call express route. Azure Express Route is extend on-premise network into Azure over a private connection that is facilitated by a connectivity, that's a service provider, ISP, like MTN, like Main1, like Glo, like uh, Verizon or Verizon, what do they call them? So you have a whole lot of them, ISP, that's big ISPs. They will create a particular uh, route or connection just between your on-premises and Azure and your Azure services, your Azure tenant. So every traffic that is passed through there is private to you and Azure, or private between you and Azure, though your ISP have control over that route. So that's the way express route, that's the way it works. So if you look at this screen, for instance, you will see private uh, um, your private or data center, your private data center. Now, the data center, this here, they call it partner edge. The partner here is actually um, the ISP. So the ISP will create a pipe between you and then Azure Edge. The Azure Edge is the VPN gateway. Sorry, is the Azure gateway of your tenant. Then from there, your user can access different services, including Office 365, which is software as a service. So if you do not want user to access their Office 365 services from directly over the internet, they can go through the express route as well to access it. So traffic to Microsoft 365 and CRM online, these are just legends for all the color that we have here. But that's express route in a nutshell. Then we talk about Azure DNS, right? Azure DNS, we know what DNS is all about. DNS allow you to be able to translate names into IP and vice versa. So you have different type of DNS that happen. You have what we call recursive DNS. We don't want to go into that, but majorly what DNS is all about, like its definition, dynamic name server or name service. So it just help you to translate name into IP and IP back into name. Remember that what computer understands is binary, right? But what we understand is name. We can easily recall name. So, and IP addresses, computer can easily convert that to binary in both binary and hexadecimal, values. But it will be too long for humans to remember or even call. So that way you can use DNS, you can use names rather. Now, these names, when the computer receive it, you need to be able to convert it into binaries. That is where that DNS translating IP to name, that's where it comes. So it's reliable. Azure DNS provides reliability and performance by leveraging a global network of DNS service uh, using anycast networking. And anycast is a form of communication that is from one to any, from one to any. So you have different mode of communication. You have what we call um, uh, multicast. You have multicast where you have many to many. You have unicast where you have one to one. You have broadcast where you have one to any, right? Then anycast is a default one on the list that is for any to any. So Azure DNS make use of this service to carry out, to perform its function. Then it is Azure DNS security is also based on Azure Resource Manager. So you have Resource Manager in Azure that allow you to be able to manage the different services that you have. It enable you can enable what we call role-based access control and monitor the Azure DNS service and also log it. So it eases the use or it eases the use of managing your Azure and your external resources with a single DNS service. So where this DNS service is usually very useful is if you go to Azure right now and you provision a service, an app service, for instance, if you want to access that website, right, that you have created with that app service, you will notice a very long name. The name will be whatever name you have called that resource while you are creating it. Dot Azure Web Service or Azure App Service .net or .com. That's what you will see. But you wouldn't be giving that URL to your customers to be used. It's too long for them. So you might want to give your customer, you might want to give them, if you want to access that website now, it can just be, that is where you now do www.tt.com or www.tt.net. Now that www, you need to tie it to an IP address, right? And then the IP address now have to be public so that it can be reachable on the internet. Who allow it to be reachable on the internet is also the function of the DNS. So that's what the DNS majorly is. On Azure DNS, you can create a record. So you will need to go and create a record depending on the type of record. Either it's called an alias, but there are different types of aliases that you can create. You can create what we call a record. A record is just a name to an IP address. You can create what we call a TXT record, that's text record. And you can create what we call mail record. So the mail record is called MX record. That's what allow your email or people on the internet to know where to locate your email. So each of these records, you are tying them to a public name or you are tying them to a public IP addresses. That is what Azure DNS does for you. And okay, before 8 o'clock. So let's see, where are we? I think okay, this supposed to have finished this week. We still have a long way to go. So just to let you know, it means we might be instead of 6 weeks, we might be using our complete 8 weeks for us to be able to cover everything. I could rush it, but I do not want to rush it for those that really want to, for us to really understand. But wherever we reach before 8 o'clock today or so, I will stop. So, or what do you say? Do you think we continue now or I continue next week? Anyone that is okay by you is fine for me. Hello. Are you guys with me? Hello.
Yes, it's you.
Okay. So what says you?
Actually tired and it's been a long day. I always look forward to having trainings in the morning, So
Okay.
honestly, I think we could stop here and continue next week Saturday.
All right.
Yeah. But let's hear from every other person.
Yes. Do we all agree?
Yes, I think that's fine.
Yes, exactly. Because I think some of you might have attended some other classes even today. So let's stop here and continue next week. So what I will do is for this week's assessment and lab, I'm going to drop it. I'm still finding it difficult to secure lab for people. But maybe Susie can you can stay back on the call. Let me see, or can you forward the email they sent to you to me? I really want to see. So right now you can log into the service again. That's Susie.
Hello, ma.
Yes.
You were saying
You
what?
can log in again right now. You can log in again to your Azure
I
again
can
now.
log
Right?
in. I can log in, but I cannot do anything because it's disabled.
Okay. All right. I hope it's not that. Maybe you have, and you've not finished the credit. Has it finished?
I think no. I just used it for the lab you gave to us last week. So I did everything. And today I don't maybe I did not do it well or something. That was what triggered them to disable my account. I don't know.
Okay. After the call, you can share your screen. Let me see what
All
could be.
right, ma.
Yeah. Okay, guys. Thank you all very much. Let's continue from here next week. And then, like I said, I'm going to drop